go ahead and get started. Thank you all for coming today. My name is Zach Rosenfield. I am a program manager with the SharePoint Online and OneDrive for Business team. This is my favorite topic to talk about, so I'm really excited you guys decided to come out for this. We're going to talk a whole lot about how we run SharePoint and OneDrive for Business. We're going to deep dive on a couple of topics. It's a 300-level session, but I'm going to kind of jump through a lot of things. So if something isn't quite for you, just hang on. We'll get to the next thing in a minute. But first, a little history. So this is my 10th year with the SharePoint team. And when I first started in 2006, there were companies both internally and externally from Microsoft who were hosting SharePoint. But the SharePoint product team ourselves, we did not actually run a hosted product that we sold to customers. And in 2009, we set out on this journey to change that and actually build the product internally in a way that we could provide the best possible service to our customers. That shipped in 2011, and I would just kind of categorize it as hosted on-prem SharePoint. We took the same product we shipped to customers, wrapped some service fabric around it, and we hosted it on the end user behalf. And then we spent a couple of years really building out automated systems. We built an entire service fabric. We really got humans out of doing manual operations. But again, it was still that same product that everyone was used to. In 2014 and into 2015, the product really started to take off. The adoption really started to grow at an exponential fashion and extremely quickly. And so we really turned our focus to reliability and scale, making sure that the service was always available and able to meet the needs of the users who were showing up in more and more every day. But now is kind of this interesting time for us. It's the first time in the history of SharePoint Online that we have been able to actually think about cloud-first technologies, things that leverage the scale of our service as well as leverage the systems and tools that Microsoft has been able to build, as well as the great network infrastructure and global footprint that Microsoft has. We're able to start leveraging that into our features, and you'll see that as we go through the presentation. The other thing is just to talk about the scale of it itself. So we are in data centers all over the world. We've been adding more and more. We just launched in Canada and the UK very recently. We have Germany coming soon. There's lots going on here, and this really speaks to that scale and that automation need where we keep doing more on a regular basis. So with that, I had to pick a few areas to focus on, and there's a lot of great talks going on this week on security, on privacy, on compliance. And so I focused a little bit on that scale architecture and cloud-first technology that we've been investing in. So we're going to talk a little bit how we scale compute, how we scale our storage, provide an endless storage system for our customers, how we balance load as we bring up those new data centers, and then finally, how we think about our platform and how we can provide success to our customers by building a better infrastructure for our system. And hopefully throughout, we'll make some call-outs for those of you who are running servers yourself. Maybe there's some things we can take away or a little bit of guidance we can try to give you. So with that, let's jump in. I like to tell stories, so I think we'll start with a couple customer examples of what it's like to run SharePoint Online, where we don't talk to the customer directly, we don't know their onboarding strategy, and so our customers often look very different. This is a customer who signed up for the service in April of 2015. Took a little while before they adopted. They have 100,000 users in their company, and you see in January of this year, they started to adopt. And week over week, more users came to the service. And you can see all the different colors. Those are different SharePoint workloads. And by the end of it, roughly 80,000 users using SharePoint Online every single day. That's great. But not every company looks like this. Sometimes companies have different strategies for how they roll out. And so we had another customer sign up at roughly the same time, and they decided to take a different approach. And in the last week of April, 80,000 users came on the first day. By the end of the first week, they had 90,000 users coming every single day. Now, no one called us ahead of time and said, hey, we're going to launch this big portal. No one comes and tells us, these are our plans, here's the timelines we're thinking. We have to be prepared for this and build a system that can react and scale when companies of this size are just sprinkled amongst the many, many different companies in the ecosystem who are all on different timelines. So to talk about how we got there, I have to talk about where we came from. This was our original topology from 2011 when we first shipped. And there's a whole lot of acronyms on that screen. I really don't intend to read them to you. What you should take away from this, though, is when you have this many different unique roles in your service, two things really happen. One, you end up with a dependency chain that you can't manage. You send a request to one role, it talks to another role, it talks to another role. Another user comes along, and they all start to intermix. If anything goes wrong with any of those roles, the whole ecosystem dies. The other challenge is you can't actually build expertise in one role. You can't get really, really good at any individual role because you have to master all of them. It became too much for us. So we sat down a few years ago and said, what can we do to make this simpler for us? And we came up with this thing we call min-role. Those of you who are familiar with the 2016 release, you'll know this term, and it really just means minimum number of roles. We sat down and said, what is the fewest number of roles that we need to run our service and scale it appropriately that allows us to actually become experts in these individual parts? And so there's three that are really key to us. We have a bot role. This is where our background processes run, where our migration runs, where our administrative tasks run. We have the user role. This is the heart of the system. This is where end user requests enter the system. This is where work is done, and we put a lot of energy into making sure that those things are available, they're clean, they're always fast and responsive. And then we have our distributed cache, DCH. And this is our in-memory cache, same as you would have if you run SharePoint on premises. We also run SQL and Azure Storage. There's a lot of great talks out there on our per-file encryption. We'll talk a little bit about per-file encryption, but I would recommend you listen to Matt Swan's talk from this week if you want to know more about how we leverage Azure Storage securely. But the main thing it does is it allows us to scale our compute independent of our storage, independent of our SQL, and we also scale search independently as well. So this becomes critical in terms of how we handle those spikes. So I like pictures. Pictures make it easier to understand. I had one of the devs actually throw together a dashboard that tries to show what the system is thinking and what it sees and how that correlates into the capacity that we allocate. And so we have this chart. And what you see is this green line that shows a pattern that aligns with the load you would see in a normal week. So this is one of our environments. I chose one kind of at random, but you see Monday, the hook, and Tuesday and Wednesday and Thursday and Friday. And this is the amount of CPU we needed to run the system at that given time. This is just actual math. In the last hour, how much did we need? How many cores do we want? And we buffer this a little bit. We want to make sure that we're safe. But the goal is to make sure that we always have that amount of capacity. The orange line at the top is just today. What is the amount of user roles that we believe that that environment needs today? And we draw that across, and it helps when we zoom out in a minute. But the yellow line is how many user roles are actually in production. And so this is the bar for the green line. So the green line is showing demand. The yellow line is showing capacity. And you can actually see when the yellow line goes up, that is new capacity being deployed by the system. There was no human involved. The system rationalized over the trend of the green and said, hey, I need to add new capacity to the system. You see little dips. I would ignore those. That's just basically we're patching servers all the time. And during a patch is when we counted the number. they come back up pretty quick. Things get more interesting, though, when we come to the right-hand side of the screen. And what we see is, first, we don't quickly react to low time frames. So over the weekend, almost no load, nothing drops. Monday, it was a holiday, September 5th. Again, we don't reduce. We expand quickly, reduce slowly. There's not a lot of risk in expanding. If you're over-aggressive, that's OK. But if you all of a sudden end up with not enough capacity, bad things do happen. And so you really see we are very aggressive about adding capacity, not about reducing. We also have this new dotted line show up. And this is where the system has actually looked at the trend. And I'll zoom out in a minute, and you'll see this trend. Has actually looked at the trend rate for growth in this environment and has determined that we think we're going to need more capacity for the load that's coming in. And so it actually starts to predict that the new load is going to be a bit higher. And you can actually see just in the little corner, I know it's a little bit zoomed out, but in this little corner, the yellow line has actually started to go up. Even though we have not committed to setting a new capacity goal, we have gone ahead and started to deploy capacity ahead of the actual need to make sure that we're ready just in case there's a little bit of a spike. We recalculate this every hour. We are constantly looking at trends from the last hour, the last 3 days, the last week, mapping out over time. And what you see when I zoom way out is this trend, where some months, not a lot of growth in load. Like in the summer months there, in June, you see a pretty flat line. But in other months, you see rapid growth. In July, you'll see 20, 30, 40 VMs are being spun up in a single week. And then at the very end, you actually notice that the peak is in August, and we start to drop off in September. But the overall capacity available to the system remains the same. So that's that slow reaction. So we are constantly allocating compute resources dynamically based on load. We're watching trends to predict growth and make sure that we're ready for that 80,000 user tenant to launch their new portal. One only slightly related call out, but I get this question a lot, so I'm gonna add it when we're talking about compute. Folks are always asking me, hey, what's the minimum required hardware that I should buy for my on-premises deployment? I get this a lot. And I just always want to remind folks, the minimum is just that. It's the minimum. And I highly recommend you understand what you're trying to get out of your system and out of your service. This chart here is just a good example. We used to run our service on these 24-disk spinning disk arrays. We evaluated a new hardware that is actually the one that we ended up going with that is SSDs. And the SSDs, you can see, we ran the exact same workload over the 2 different drives. And at the lower percentiles, which is where if you just ran a test, you just said, hey, I'm going to try out this request and see how it runs, it looks about the same. But at the higher percentiles, how the thing behaves under real load, significant improvement in performance and differences. So just keep that in mind when you're looking at hardware for your own deployments. The hardware you buy has a direct impact on customer experience. OK. Moving on to everyone's favorite topic, storage. We like storage. We have lots of it coming in every day. So how are we ready? I don't get to talk about many customers, but I do get to tell real numbers with MSIT, so I always start here. And I've actually been doing this talk for quite some time. So I did this talk in 2014 at the SharePoint conference that spring. And the MSIT tenant had 60 terabytes of data. I actually remember being on stage talking about how big the MSIT tenant was. 60 terabytes of data, 55 terabytes of that was OneDrive for Business. And that was actually really exciting because the on-premises deployment at MSIT didn't have that data. It was new data that was now under IT control because it was on desktops. It was maybe on some file shares, but now it was being put in the cloud. And then last spring, so just 2 years later, I did this talk again. And 10 times, 604 terabytes of storage. We had grown 10x in 2 years. And big growth in OneDrive for Business, but also it was great to see lots of growth in SharePoint sites. In fact, twice as much storage in SharePoint sites in those 2 years than MSIT had seen in SharePoint sites in all the rest of time. So huge growth, great adoption, 184,000 users using it every week. But that was 6 months ago. So in the last 6 months, we've gone up to a petabyte. So accelerating in growth, continuing to see great growth in both OneDrive for Business and in MSIT content, more users, and even more syncing. And I don't think we're done. So this is great, shows you the scope and rate of change. But I also like to call out that MSIT is not the largest customer in the service by any of these vectors. There is someone larger by all of these data points. So how are we handling it? Well, this journey actually started in 2014. The service was growing really, really rapidly. And on top of that, we had some really tough limits in SharePoint. Just bonus points. Does anyone know what the single tenant limit was in SharePoint Online in 2014? Anyone? It was 25 terabytes. That was our limit. A tenant of SharePoint Online was not allowed to be bigger than 25 terabytes. That was our system max. And no one actually was that close to it except for MSIT, but it really actually was our published limit. And so we said that's got to change. Our databases are getting really big. What can we do? We took a look inside. Said, hey, there's lots of files inside of our databases, and Microsoft has this really great system for storing blob content up in Microsoft Azure. And so we took that opportunity to move the content over. And this is that per file encryption story that is not only a great opportunity for us to scale better, but was a great security message and a great story around how we actually can secure your content better in this new model. But as a result, our databases were a lot smaller, and we could start to handle scale and offer new features and functionality within it. So with that, we'll take our first storage deep dive. I also get this question a lot. SharePoint Online, you're announcing these new big limits. You're upping your site collection size. You've got all these new great numbers. Why can't I do that on premises with RBS? And so quick interlude as to the difference between RBS and per-file encryption and why it impacts things, but also why per-file encryption is fundamental to how we scale and handle storage at these numbers. So 2013 RBS, it's actually a feature of SQL that we exposed in 2013. And really quickly, the flow is a file request comes into the front end, passed along to the content database. SQL, behind the scenes, SharePoint doesn't actually know whether the file is stored in SQL or not, sends a request out to the blob store, which will send that file back to the SQL machine, back to the front end, and eventually back to the user. So lots of different machines involved, and this abstraction layer in between SharePoint and the blob store. There's lots of challenges with that for us, lots of limitations, and it didn't quite meet our needs. Per-file encryption, on the other hand, same exact scenario. User requests a file. You get the location and the key for that file from the database. There's additional opportunity for us to add another encryption layer on top of that key. Again, Matt Swan had a great talk on that this week. But then we go directly to the blob store, Windows Azure in this case, request the file, send it directly to the front end and directly to the end user. And it seems like a little difference, that one less hop. But it actually makes a big implication for us in how it impacts our system. First off is that permissions difference, that you only need access to the individual blob. But additionally, and this is important for us, it lowers the impact on SQL, which gives us opportunity to put that I/O to a better use. And so it sounds really technical and kind of abstract, but under the hood is the key technology that is enabling us to do things like larger site collections, like active-active storage. So this is actually allowing us to, behind the scenes, request from Azure in one location, and if Azure is having an issue, go to another location and serve that request without ever telling the user that the initial location was down. It's allowing us to do things like customer-held keys and much more. There's things in the pipe that all depend on this technology, and it's fundamental for our system and how we do work. And I'll add, because my team doesn't get to say exciting top rated items all the time, but I know that storage is important to everybody out there, and we know that it's a big deal, and so we're focused on making sure you always have enough storage available to you when you need it. OK, we talked a lot about how we actually manage the resources that we have. The next part, though, is actually getting people to where the resources are. So we had this thing that we internally called the Hotel California problem. If you're not a fan of the Eagles, there's a song, Hotel California, where they say, you can check out, but you can never leave. And we ended up in a situation where we built new data centers, and our best customers had been using us for years and couldn't get to the right place. They were stuck in the wrong location, and that was a challenge. We wanted to make sure that just because you signed up a year ago, you weren't limited in where your data could be stored. So those of you who know SharePoint know that your database structure looks something like this. You end up with different databases for every single product service in the system, and your data is spread without. And in SharePoint Online, this actually meant that individual customer data was spread across all these databases, intermingled with that of many other customers. And so to move a customer from one region of the world to another, you had to suck their individual data out of that database and stitch it back together into another one. And this was a big challenge for us. It was fundamentally the thing that was holding us back. And so as of now, we have actually converted our entire underlying system to have one database. So the content database that stores the core customer data now also stores project, stores taxonomy, stores BDCs, stores all the different data sets. And so we can actually move a customer just by moving one database. It also means we don't have to coordinate across different databases and impact the different experiences. One database is impacted, and it solely impacts that customer. Now, this doesn't mean every customer gets their own database, but it does constrain the scope of the challenges. So now that we have that, we have an opportunity. Because a customer's data set becomes their content data, their search signals, and their search index, and those blobs we talked about previously. And so now we can actually go ahead, take a point-in-time copy of all of that data, send it over to a new location, and then only briefly lock the customer data, do a differential, and in the end of it, we had the customer move from one location to another. At this point in time, we can do this entire operation for a tenant of any size, and we have moved our largest tenants using this technology. We can do it for a tenant of any size in under 2 hours of read-only time. And we are continuing to make that better every single week. OK. We move on to my favorite part of the talk. So we like to think about the platform as not just the platform that we run or the service fabric, but we like to think of it actually as a platform for customer success and making sure that the work we do is focused on helping end users have a better experience with the SharePoint Online product. And so there's a couple of ways that we can do this. And the first thing that we can do is leverage the massive amounts of data that we have been able to gather about end user experiences, about platform latencies, about issues around bandwidth, and start to both change the system for the better, but also to add new features and functionality that better fit the problems that customers are running into. And so we have added a lot of instrumentation to the base platform so that we know what's going wrong. But then we can actually do analysis between tenants so that we can find issues that tenants will have or provide guidance or recommendations for common issues that other tenants have experienced that might be in a similar situation as yourself. Great example here, we've been able to correlate failures or slowness across internet service providers and help our networking team figure out which ISPs they are doing a poor job of peering with or need to change peering relationships with. We had a situation in France where a region of France appeared to be very, very far away from our system, whereas the rest of it was doing fine. We were able to look at it and figure out that that was an issue with our peering. And so we can correlate those things by looking at these similarities. Another one that I like to mention, because we actually announced a new feature as a result of this analysis just this week, we were looking at the portals that folks were building. And we found that a significant amount of time was spent waiting for resources such as images, JavaScript, CSS, common elements that in a traditional public forum you would post on a CDN. So instead, they're waiting for SharePoint. They are going through authentication, they're getting it from the database, and they're not being able to take advantage of those global delivery frameworks. And so we wanted to make sure that end users were able to get that performance benefit, and so we've actually built a feature where there's a blog post and a talk this week on it, but a new feature where customers can now publish their own content to our CDNs. We have it set up. We have the global distribution set up already. But you can just mark your content in the right way, get it published to the CDN, and get that performance benefit, and actually see that yourself in a way that we have been able to notice across these different environments. So this is a real customer data here. You can actually see images spending 160 hours of wait time in a single day. End users for this customer spend 160 hours worth of time waiting for those images to get served from our servers, whereas they would wait a fraction of that if those were delivered from a content delivery network. The other side of platform success is actually on the service side. And our service has been getting really, really big. We have thousands and thousands and thousands of servers. And so making sure that we're able to keep the service healthy has been a big challenge for us, and we've invested a lot in the last few years. So the first thing is generally you're seeing lots of new features, and that code is never perfect. I'm sure our developers like to think it is, but it's never perfect. The other thing is that anything that can happen will happen. You know, you always hear the statistics when you're buying new servers, and they say, you know, odds of a hard drive failing, the odds of 2 hard drives failing at the same time, the odds of a router failing. We have reached a scale where it doesn't matter what the odds are. I know it's going to happen. It's just going to happen. And so we have to be prepared for the eventuality of those failures and just know that we need to react to them. The other element there is manual investigations do not scale. We actually used to be in a place where every time there was a failure, a bug would get logged, and a human would go look at the server and say, oh, the hard drive was bad on that one, and over here we had a SQL timeout, and we looked at every single server. And as you can imagine, that does not work anymore. And so we've actually built a machine learning system that helps us to identify patterns and also track those code changes back to the originating team. I'll show you a picture of that in a second. The third thing is a little bit obvious, but always has to be said. You just want to recover quickly. You want to try the obvious resolution. Server's not responding, reboot it. Having an issue with a machine even after that, take it out of rotation if you can. Just try the obvious, see if you can resolve the issue quickly, and clean it up later. The other thing is we used to be in a world where to change things, we would actually write new code. And this has been a fundamental challenge for us. You never want to be in a situation where you always have to create new change to solve your previous change. And so the ability for us to turn things on and off, new code on and off, without writing additional new code, really sped up our resolution time. And the last thing is we have this issue with decay. We find that over time, the machines decay if they're just left untouched for long periods of time. And this is just the mix of patches, the mix of changes, the memory situations. And so we actually try to always harvest our VMs. And so our system, at least for particular roles that we care a lot about, our system is constantly watching for machines that have aged out and haven't yet been replaced. And we're replacing those machines under the covers. So a quick example, in most of the cases, the system is able to auto-recover. Probably hard to see in the back, so I'll talk you through it a little bit. The system is usually able to auto-recover, so I wanted to talk about an example where we had a developer introduce a change that caused an issue, and we weren't able to automatically recover from it right away. And so on September 15th, our Australia 2 environment had an issue, and if you can read the reason column on the right-hand side, we had a latency violation in the 95th percentile. So we look at the 95th percentile in addition to a few other percentiles for performance, and the speeds that we were seeing in the system did not meet our expectations. And so an alert went off. And we actually had a couple of things happen. First off, it actually is already assigned to a team. So this is assigned to the POP team, the People and Org Platform, or POP team. And we think that it is definitely, strongly stated, their service calls. And we also notice it's impacting 49,000 tenants. That's a lot of tenants. We want to make sure we get that resolved right away. And we also have a link to a bug, and that bug is actually where it says, hey, we tried to see if we could reboot or do something like that to fix it, and it didn't work. So it went ahead and assigned it to the team directly. The on-call engineer actually received a phone call and was right away working on that problem. But if we look at what the system has done underneath, is it's actually gone ahead and said, hey, I see a lot of calls to this, the second row there, this unknown tag pair, ADLMZ. So that's actually the code is tagged, and in between those two pairs, we spent a lot of time. And we're not quite sure why, but that was under the wider scope of this POP team system. And if I zoom out again, if you can actually make it out, there's a whole lot of requests before that for that unknown tag pair, that ADLMZ. So we had a bunch of violations within an hour for this one code path that's all exhibiting the same impact, and it's wrapped in this wider set of code that is owned by this POP team. And so we're able to actually quantify that wider set. We don't know what the code is. It turned out to be brand new code. But we knew what team owned it. We could route it directly to that developer. And within that same hour, the issue was resolved, and it never shows up again. And so we've had to do this because the number of environments, the number of areas where the issues come up, we previously would have had to actually look at each and every one, investigate it just to figure out what team to engage, what developer wrote the code, when did that happen, and hours later, maybe even days, we would correlate that information, figure out who it might be, and actually get that problem resolved. And so it's all about reducing our time to resolution, about automatically figuring out where the change occurred and how we can, as quickly as possible, resolve the issue. So last topic, this was a short session, so I tried to cram as much as I could in. But I want to end on what I think is a very high note and talk about a little bit exciting new stuff, really focusing on the last mile. The last mile is everything between our data center and the end user. So this includes the internet service providers, this includes the corporate networks, this includes the hardware that the user is using, everything between the end user and the stuff that we directly own. This is responsible for almost all of our customer support calls that are tagged performance. If you call and say performance, a significant majority of the time, we will resolve it by dealing with something in the last mile between us and the end user. And so it's a little bit hard for us to do, but one of the things that we can do is try to get closer to our end users. And so we're actually running a tap of this now. And I'll walk you through what it looks like, but I can actually show real numbers because we have real customers in this experiment. We took a large file, a significantly large file, so we could talk in whole numbers. And we worked with a customer who has a data center in the Midwest and an office in the West Coast of the US. And they were able to upload this large file. The average was about 3.6 seconds. And that guy was happy, and he's able to upload his file quite easily and deal with this close data center. But the same customer has an office in Singapore and wants to collaborate with other users in Singapore. And that exact same file from Singapore going over a last mile that we don't control, so I have no idea, did it route west, did it route east, how did it get to us, I'm not sure, but it took 15 seconds. 12 extra seconds, almost 5 times as much, and 12 seconds is a really long time. If I just counted to 12, you'd all get really annoyed with me. So what can we do to address that? Well, we have a footprint. Microsoft has a footprint all over the world. We have an incredible network, and we can take advantage of it. And we actually have an endpoint in Singapore proper. So instead of advertising that SharePoint is located off in the Midwest for this user, we advertise that SharePoint is located in Singapore, and we take the request locally. And instead of going over an unknown route, they go over a Microsoft route. It's our route. We maintain that it has enough space, that it has enough bandwidth. We maintain the route. We can optimize and actually go beyond and do cool things where we keep the connection warm. And as a result, that exact same file takes 4.2 seconds. And 4.2 seconds versus 3.6 seconds, considering they are 8,000 miles apart, they are a 17-hour plane trip in between the two, is a pretty small difference, and is actually enabling 2 users across the world to work on a single file in a near real-time experience without all of the unknown. And so there's still a last mile. There's still a piece we don't control. But our plan is to expand the last mile and get closer to the end users wherever they may be and allow global corporations to interact on files in a somewhat transparent to where my data is type way. So this is in preview today. We're hoping to roll this out to our environments very, very soon. It'll hit ring 0 in production here quite soon. If you don't know what I mean when I say ring 0, or you want to know why I'm not up here saying, hey, this is really cool, it'll be live tomorrow, I highly recommend you go to this talk. It's actually in the room next door tomorrow. Learn how we move fast without breaking things. My peer, Zohar, will be talking about our rings, change management, and how we roll things out to avoid disruption. So with that, I actually only have a few minutes left. So I wanted to say, we talked about storage, we talked about compute, talked about balancing load, and how the platform is optimized for gaining insights about how people and users are using the system so we can feed that back in and have a better overall user experience. And so with that, I just will say thank you, and I'm here for a few minutes and can answer questions.